Today we're going to be looking at MVC, Model View Controller, how that fits into Java Server Faces, and we'll also introduce an extra concept in JSF so that we can display our data in some tables. There are two ways of doing that. We'll only look at one today. We're going to think a little bit about software architecture and what that brings to the table in terms of our designs of applications. We'll think a little bit about the MVC architecture, explore what that actually means and the benefits that that can bring to our applications. Then we'll see how to do that in JSF, and finally we'll look at how to display tables in JSF. Now this means that you're going to need some concepts from previous learning blocks, JSF of course, managed beans, JSF life cycles, all of that from learning block 1. Also how to use prepared statements from the last learning block. Remember, we use prepared statements wherever possible because it introduces a layer of security that prevents attacks such as SQL injection. Now the concept of a software architecture is really an abstract concept. It allows us to think about our applications in a very abstract way. So we will be describing the architecture, that is the major components of our applications in terms of these abstract components. We will talk, for example, about a model component or a view component or a control component. And once you understand what model and view and control components are supposed to do, that will immediately convey to you the concept of that particular component in general terms. And then, of course, we have to apply it to a specific component. So we might want to have a model component that updates a customer. Well, I can talk about a model component once you understand the MVC and you'll understand what the model component is supposed to do. Then we can take that into the update customer and then apply the general concepts to the specific scenario. And you'll be able to do it in such a way that it will fit very nicely with all the other components in that architecture. So these are some of the advantages that go with architectures. It allows us, because of the abstraction, to reduce complexity until we actually need to focus on the fine level detail. Remember that abstraction really just filters out the low level detail until you need it, which allows you to keep the high level detail. A very easy way of illustrating that is the concept of bicycle. That one word conveys in your mind immediately an image, and that image tells you everything that I want it to mean. It's only when we come to maintain the bicycle, or we come to riding it, or we want to stop riding it safely, that we then have to know a little bit more of the detail of what a bicycle is. And it's the same with our applications. We can have the architecture and talk about these general components, but it's only when we want to focus on a specific component in its detail that we need to focus on the detail. Until then, we can leave the detail alone. It allows us also to do this software engineering thing called separation of concerns. It allows us to separate responsibilities and to assign those responsibilities to specific components. And that's a very strong aspect of software engineering, and it also means that you get very good quality applications when you use this concept of separation of concerns. We'll explore that a little bit as we talk about MVC. Now those components, they'll have general properties and relationships and interactions, and I'll show you some diagrams in a minute of how that works for MVC. The great thing about that is by defining the general properties and relationships and interactions, whenever we want to build a specific example of one of those components, we immediately know what kind of properties and relationships and interactions it should have. So the architecture is going to guide us in the kinds of components and the structure of those components and the interactions of those components. And in that way, it's going to help to standardize the design. Now, having a standard design is really quite useful when you're building an application. It doesn't mean to say that every single application will always have the same design. What I mean by this is that within that one application, your design will be standard. That is a very useful thing to have. When you're maintaining it or building it or debugging it, when something goes wrong or you want to extend it, you know exactly where to go if there's a problem or there's some enhancement to put in. When you're working in a team, as you usually are, having this standardized design means that you've got a common understanding of the architecture and therefore a common lexicon, a common vocabulary that you can use in the team. In the same way as we can talk about bicycles and you immediately know what we're meaning, so we can talk about the update customer model component or the update customer view, and we know what we're talking about once we've understood what this architecture is about. As I've mentioned already, it enhances the quality of the design and thereby also the implementation, improves the maintenance task by making it much easier. When you get a thing go wrong, you know exactly where to start looking. If you structure it really well and use this separation of concerns to full effect, you will probably only have to go to one place in your entire application when one thing goes wrong. That would be a good test of how good your structure is, if you've only got to go to one place to correct one error. And it also improves extensibility because we can add new components in without affecting other components that already exist. And that's also another good test of the quality of your application, if you're able to add in new components without having a knock-on effect amongst the other components. But there are some disadvantages. You've still got to think, but perhaps you've got to think a bit more. There's this cognitive overhead, and sometimes it might be a bit difficult to know just how to map what you want to do onto that architecture. But the advantages that we've just talked about are benefits that really outweigh this extra thinking that you've got to do. There's a design overhead, in as much as you've got to spend time designing the architecture before you actually get on to designing specific components. And that takes time, it takes effort, it takes money when you're in a company. But that, of course, is amply offset by the improvements in quality, extra ease of maintenance, and so on. But having an architecture also imposes a degree of inflexibility, because if you're going to impose a structure, then insist that everybody in the team fits into that structure. That means you can't then go off and do your own thing. You can't go off and do your own tricky programming just to show what a clever programmer you really are. That doesn't work, not in a team environment. Everything you do should fit within that architecture. So what if you want to do something that is tricky and it doesn't fit with the architecture? Well, think of a way of fitting it into the architecture. There will be a way if it's a good architecture. But of course, that lack of flexibility is offset by this improvement of standardization. The usefulness of standardization means that everybody knows what's going on. You might fall under a bus tomorrow and not ever come back to work, and your bit of tricky code can be understood by absolutely nobody because you're the bright spark, you're the genius that wrote this awful code. Nobody else knows how to use it. What are they going to do when you don't come back to work? Well, they're going to throw it away and have to rewrite it. So let's take a look at MVC. It is an architecture, sometimes called a design pattern, but it isn't. It's an architecture. The acronym means Model View Controller. It's all about separating responsibilities, separation of concerns. So the first area of responsibility is the model, which is separate from the view, and both of these are separate from the controller. The model's job is to work with the data in the application and also to apply the related business rules to that data. You might, for example, have an insurance application where you need the date of birth of the applicant. But you might have a business rule that says we will not insure anybody under the age of 18 or above the age of 50. That's a business rule. That's not anything to do with date of birth. That's a requirement of your business. And so the model component, when it receives the data, will perform its checking to make sure that those business rules apply to that particular proposed insurance policy. The business rules govern the use of the data. The model will ensure that that data is used according to the business rules, will ensure that the data is stored in the appropriate places, database for example, will ensure that whenever there is a change of data values, that those changes are propagated through the system as appropriate. The view has one responsibility: present information to the user. It should not be changing data. That's the job of the model. Therefore, it will take information from the model and present that information to the user. The other element is the controller. Its job is to manage interaction between the system and the user. So the user will send requests to the control servlet in JSF. It might not be a servlet in other applications, but this controller will receive the requests. It will then decide, based upon the information in that request, which model components to activate and then which view components to display. So we get this request-response cycle that we've already seen in the previous learning blocks. That's why MVC is really quite a nice architecture to use in our web applications, because our web applications revolve around this request-response cycle. Each request will come to the controller activates the model components that are needed, the view components that are needed, and then that's the response dealt with. Here's an example. Some input comes in, that's number 1 on the left. The controller receives it, updates a model, just one model component, and then number 3 renders view number 1. As part of rendering that view, there'll be a read of the data that's in the model, and the output is the rendering of that view in response to the request that came in. So a very simple little example. Take that example and replicate it 1,000 times and you've got quite a complicated web application. You've got a very simple architecture, and the great thing about a simple architecture is that it's easy to understand and can be used over and over and over again with lots of different requests. And you've got a standard approach to every request. Let's extend the concept a little further by introducing this idea of separation of concern. Remember, we said that model is separate in its responsibility from view. The model deals with the data, the view deals with presentation. Let's go now and think about separation of concerns between model components. You might have a model component that says update and display customer. As soon as you hear the word and, alarm bells should begin to ring. The word and means that you've got two things going on. And if you've got two things going on in one component, then you haven't done enough separation. So split those out. Do one component that will update and another component that will retrieve information. Now you've got two components. But the great thing is, because you've done, as it shows on the slide here, you've now got one functional operation per component. It means that those components can now be reused much more easily than if you're doing multiple functions in one component. Have one functional operation per component. We can do the same with the views as well. We've already seen in a previous learning block how we're able to combine different aspects of views, and we'll talk about it much more when we think about templating. But we can take view components and identify this one little bit of presentation that we want to use and maybe even reuse. And then we can combine the view components to produce one view. We'll see examples of that over the coming learning blocks. So what about this update customer as a specific example? Well, the controller will receive the request, but now it will invoke two model components. First of all, to update customer, including storing the data in the database, and then to retrieve customer from the database, ready for the view to be rendered and produce the output. The controller's not invoking anything for number 5. What will happen is that for operation number 3, retrieve customer, in some way that will depend on the specific application, the data retrieved by this model component will be made available for the view component to access. Now in Java Server Faces, that means in the backing bean. If you're using a servlet JSP environment, then you will probably get a POJO and put it in as an attribute on a scope, so that the view component can then retrieve that attribute from the scope and make use of it. All kinds of different specific implementations of this general concept. And that's an important realization, that this is a general concept, and you will need to find a way of adapting it to your specific application. The two previous examples of MVC were single request to a single controller. What we're going to do in this configuration is to show two user interactions with a single controller. So the first request will come to the controller, invoke one or more model components, invoke one or more view components, produce a response. the next request to come in will also go to the same controller, and it's very probable that a different combination of model and view components will then be invoked in response to that request. And so it's up to the controller to work out which requests are going to invoke the different combinations of model and view. What this illustrates is that you don't have to have one controller for each interaction. You could have a single controller for every single request type that would come in from your users. Or you could go somewhere in the middle of those two extremes. You could have one controller to deal with one type of user requests. So for example, student requests will all go to the student controller. Lecturer requests will all go to the lecturer controller. Admin requests will go to the admin controller, and so on. So you're able to separate responsibilities, separate concerns in that way if you wish. For our purposes, we'll just have one controller for the entire application. In part, that's because that's what we're going to do with JSF. Let's see how JSF implements MVC. Well, first of all, it enforces a very clean MVC. The view, well, that's in the XHTML files, the facelets. The models, they're in the backing beans and other classes that the backing beans make use of. And you're not really able to mix those two. JSF makes a much cleaner separation of things. The controller is going to maintain the life cycle of the Java objects, the model components, the backing beans. It's also going to use XML files and Java annotations to define specific responsibilities. Think about, for example, a managed bean. You have an annotation right before the class declaration that says this is a managed bean, and immediately that assigns a whole set of responsibilities to that managed bean. And the controller will then interact with that class on the assumption that it meets those responsibilities. And that's the idea of inversion of control. You specify an interface, and then you write classes that meet or implement that interface so that other components can use those classes, safe in the knowledge that it's operating according to the interface. And that annotation that we put in there, the @named, is actually an interface, which will mean that the control servlet is able to use our managed beans, correctly assuming that this is a managed bean, and will know what methods to call, when to invoke them, when to instantiate the object, when to destroy the object. We'll put the business logic in POJOs. We could put them in the managed beans, but as we come along a little bit further in our learning blocks, we'll see that we want to use POJOs to do all kinds of extra stuff to keep the managed beans much simpler, much cleaner, much leaner. And the component-based user interface, again, very clean separation of responsibilities. The facelets that are defined in the XHTML files contain UI components that have been defined elsewhere. That's why we use the XML namespace annotation on the HTML tag to make those libraries, those tag libraries, available to our facelets. And those components will then behave in a way that is previously defined, in a predictable way. That means that we can use them knowing that they've been tested. We don't have to keep testing them over and over again. They will behave properly. We can make use of the one definition wherever we want it, in as many files as we want to make use of it, and it will always behave in the same way. Reuse of components is a very strong productivity tool in terms of our application development. It also means that we don't have to keep writing lots of low-level HTML, because those tag libraries define the HTML that will be produced when we make use of one of the XHTML components. So how does it work? If we take the update customer example, then the controller, well, that's going to be the control servlet, and that's written or provided in the framework. We never write the control servlet ourselves, so we don't have to worry about the controller. That's done for us. Its life cycle is defined, and all we've got to do is to write model components and view components that fit into that framework. Update customer, for example, would be a method in a backing bean, or at least would begin there. It might well then be that we write a POJO that has all the SQL interactions with the database, and that this method in the backing bean will simply call a method in the POJO. Keeps that backing bean small. Now there are different viewpoints about MVC. There's the view from the user's position, and there's also the developer's view. From the seat of the user, all that's going to happen is, oh, here's a view, type in a value in the text box, click the submit button, move to the next view. So as far as the user is concerned, what is typed here will end up there. And the user does not need to know, indeed doesn't care, how the text typed in the text box ended up on the next view. But of course, from the developer's point of view, your view and my view, it's very different. We've got to know what goes on in the background to achieve what the user is expecting. And so our viewpoint is that we've got this initial view, index.xhtml, that's got the UI component with a text box, and that request, when the submit button is clicked, will be sent to the control servlet. The control servlet will update this user model component, which is a backing bean, and then invoke the next view to be rendered, which will retrieve information from the user backing bean and display it as the output view in response to the request. So that's the developer's view. So breaking that down, here's the XHTML for the facelet, and you can see that we've got a form which is represented in this tree, component tree. There's an input text and a command button, both of which are represented in that component tree. Then we take the component tree and populate it with values from that view. So now the input text has got the value typed by the user, and the command button has got the value that is on the front of the button. So now we've got this component tree populated with values from the request. Those values will be converted and validated, and when everything is okay, those values will then be transferred into the managed bean. And that's where the set method is needed. So remember, these managed beans have got properties with associated set and get methods. When we're taking values from the input component tree to put them into the managed bean, it's the set methods that we call. And then to render the response, another component tree. Now we're going to build that component tree based upon the XHTML for that output facelet. The get methods will be called to retrieve information from the managed bean and insert them into the component tree. And then finally, that component tree with its values will be used to render that view. So let's introduce a little bit of extra JSF. We want very often to display information as tables. And in JSF, there are two major ways of doing that. There's a component, a UI component called panel grid, and there's another one called data table. Today we will look at panel grid, which has a fixed number of rows and columns. Data table will have a fixed number of columns, but the number of rows will depend upon the number of objects that we give it in a collection. We'll look at that in a later learning block. Both of these elements are in the HTML library, which is in the namespace that's highlighted in bold at the bottom of the screen. When we're using a panel grid, very often we'll make use of a panel group as well. The panel grid, when it is rendered, will appear as an HTML table element. When the panel group is rendered, it will appear as an HTML span element. Now, when we have components inside the panel grid, each component will occupy one column in a row, and they will be mapped in this way. First of all, when we define the panel grid element, we specify a number of attributes. Columns will tell the renderer of this grid exactly how many columns to use. So it doesn't matter how many bits of data you put in between the panel grid and its end panel grid tag, there will only ever be 2 columns. Or if you make that 4, there will only ever be 4 columns. The next 2 attributes that I'm displaying here, header class and column classes, they are the names of the CSS definitions. So if you've got a particular style that you want to use for the header row, then header class equals and then the name of that style. If you only specify one column class, then that is the name of the style that will be used for every single column in your table. If you specify more than one, then they will be used in rotation. Here we've got 2 columns defined and 2 column classes. So the first style will be used for the first column, the second style for the second column. And the other attribute that I'm showing here is not limited only to panel grid. You can use it on any of the UI components. Rendered equals and then either true or false. If it's false, then it doesn't display. So what's the point of having it? Sometimes you might want to render a value if a certain condition is true and not render it if that condition is false. And what we can do is use the expression language to call a method that will return either true or false. For example, if we have, let's say, the managed bean has got some data, if that data is of a particular value, we don't want it to be displayed. And therefore, we would say rendered equals hash, open brace, managed bean dot method name, close brace. That method will be called. If it returns true, the table is rendered. If it returns false, it isn't. So that can be quite useful, and you can use that on pretty well every UI component. So let's put some data into this table. You can see on this example, the panel grid is defined with 2 columns and ends down here. Now I've got a space between these 2 pairs of components, but that space is completely meaningless in terms of presentation of the actual data. That's there simply for aiding the readability when you and I come to read the code. The way that it works is that each UI component will be placed into its own column. So this first component goes into column 1 of row 1. The next component will go into column 2 of row 1. The third component will go into, well, we've now filled both columns on that first row, so it's now going to go into column 1 of row 2. As these components are encountered, they will be used to fill the columns row by row. And that means that we've got to be careful about the order in which we specify these components in between the panel tags. Here I've got an output text with a value, which is the label. I always want the label on the first column and then the value from the managed bean in the second column. So I've got to make sure that I always specify it in that order. Label, value, and that will come out row by row because I've said this panel grid has only got 2 columns. Sometimes I might want a label and a value to appear in just 1 column. But if I do it like we've got on screen here, that will never happen. We'll have the label in 1 column and the value in another. And that's where the panel group becomes useful. When we put something in a panel group, it effectively becomes 1 group that will occupy 1 column. So now, with exactly the same code as we had on the previous screen, except that we've got these 2 groups, we can see that this group is going to occupy 1 column. In that 1 column, it will have a label and a value. And in the next column, there's another group of label and value. We've now got only 1 row in the panel grid, whereas in the previous example, there were 2 rows. So by the time you've finished all the exercises on this learning blocks worksheet, you should then be able to understand not only what an architecture is, but the need for it. You should be able to describe the MVC architecture, describe how that is used in JSF. You'll get plenty of practice at doing that in this learning blocks exercises. You should be able also to use panel grids to display data in a table.